a sub k plus 1 equals b sub k plus 1. Right? That's what we just showed. Is that for any number, when it's true, when this equation is true for that number, it's true for the next number. So, by the principle of mathematical induction, what am I entitled to conclude? It's true for all numbers. How do you feel about this?
That makes total sense.
It makes total sense. Good. I like that answer. Okay. Yes.
You told me to bring up the fee thing that we should like by this.
Terrible time. I don't even know what you're talking about anymore. Okay. Good. So let's do another one. I can't even remember what I want to do next. I guess I want to do this one next. Yeah, sure. Okay, here's a fact. Here's a theorem which might be true. Hopefully it is. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus dot 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 plus 1 over n plus 1. Okay, I can like experiment. Oh, should we do the experiment? Yeah, let's do the experiment. That's kind of fun. What do we think this is equal to? Let's play a game of guess and check. This is like real math. You like conjecture and then you prove. So how can we conjecture? You did almost this exact problem for homework. I'm pretty sure it was this exact problem you did for homework. What is the sum of the first 1 terms?
1/2.
1/2. What is the sum of the first 2 terms?
2/3.
2/3, says Nick Healy. What is the sum of the first 3 terms?
3/4.
Is that true? 2/3 and 1/12? Is he right?
Yeah.
8/12 plus 1 is. Are you just remembering the problem from your homework?
Yep. Yeah. It's kind of
Okay, the sum of the first 4 terms. I guess that would be like 1/20th and 3/4
4/5.
is 4/5. Okay, good. So on the homework, back when we were just children last week, we just had to say like, oh, so by the way, what do we think the pattern is? N over n plus 1. So last week, when we were just children, we had to just hope that that was true and just hope for the best. Remember we had a whole conversation? Did we have a whole conversation about this?
Yeah.
Hopefully we did. Now, Juliana, now we can prove that this is true. And really the only way to prove that some kind of number pattern is true is to prove it by induction. It's the only way. So Will, there's kind of like 2 steps going on here. I want to make clear how math works. The first way math works is you just play or you just screw around basically. You play, you guess, and you hope for the best. And then now we think we know something. And then the other important step in math, both important, I don't know which one is more important, you prove that you're actually right. So everybody with me? Okay, and so for purposes of being able to like speak about it smoothly, let's nickname this expression a sub n, and let's nickname this expression b sub n. And now, what is it that I'm actually trying to prove? Goal. Yes, but I want you to say that a little bit more carefully. I want to prove that a sub n equals b sub n for all n. I need to prove that this formula works for all numbers. And I guess again I'll start with n greater than, I'll start with 1 in this case. Okay, how do we do this? Well, there's the base case, or the base step, whatever you want to call it. In the base case, you just check to see if it's true for 1. Well, what is a1? 1/2. What is b1? Also 1/2. So a1 equals b1. Okay, so what we just did is we just checked to see if we just checked by brute force to see that it's true for the first number. It's true for the first number. Okay, now comes the inductive step. And in the inductive step, we make our inductive hypothesis. And what is our inductive hypothesis? Okay, I'll just tell you that a sub k equals b sub k for some k greater than or equal to 1. So I'm picking an arbitrary k, and I'm supposing that my statement is true for that arbitrary k. And then what do we need to prove?
That a sub k plus 1 equals b sub k plus 1.
Yes. Try to prove that a sub k plus 1 equals b sub k plus 1. And I think that this is like relatively easily done, right? Do it right now. The algebra is easy. It's the logic which is kind of tricky. You guys want help? Maybe I'll just give you a tiny bit of help. What is a sub k plus 1?
1 over 1 times 2.
1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus all the way up to the kth term will be 1 over k times k plus 1, right? But I want to know what a sub k plus 1 is. So a plus k plus 1 means I go out to the k plus first term. Nod vigorously if you understand what I'm talking about. So then this should be 1 over k plus 1, k plus 2. I didn't really do anything fancy there. I just wrote out what the meaning of a sub k plus 1 actually is. A sub k plus 1 means just keep adding terms until you've added k plus 1 of them. Kellen, you with me? Okay. Now what?
Actually,
Just a sub k.
Yeah, all of this is just a sub k. Yep.
And since we've already done that a sub k equals b sub k, we can do that.
Yeah. Now we use our inductive. Caleb, are you okay?
Yeah.
Now we use our inductive hypothesis. Our inductive hypothesis is we assumed that a sub k equals b sub k, so then I can just like sub that in, right? And then just like finish it off. What is b sub k?
K over k plus 1.
It just is by definition k over k plus 1. Now I have this kind of like algebra thing going on here, and it's pretty obvious what to do, right? Get a common denominator. You guys work out? You get a common denominator, you multiply things out, you factor, you cancel, and we end up with
K plus 1 over k plus 2.
k plus 1 over k plus 2, which is b sub k plus 1. In other words, success. I have showed, equal. I have showed that starting with a sub k plus 1, and starting with what a sub k plus 1 actually means, that it's really just a sub k plus the next term. And now the key step, of course, was right here, where I used the assumption that a sub k equals b sub k, then the algebra just works out, and I've shown that it's b sub k plus 1. In other words, this property, the property that a number has, that it makes this equation true, that property is held by the number 1, and whenever a number has that property, it's inherited by the next number. And so I've showed it's true for 1 by brute force, and I've showed that when it's true for 1, it must be true, when it's true for a number, it's true for the next number. So if it's true for 1, it must be true for 2. If it's 2, some teachers think about this as like dominoes, right? If you can prove that like, well, whatever. All right, so now you have the magic sentence, and the magic sentence is, well, I'll tell you. It's true for the first number,
Check.
and
It's true for AK, right? For
if it's true for k, then, I'm using like arrow for if then, I don't care with that, right? If it's true for k, then
it's true for AK plus 1.
it's true for k plus 1. We showed that it's true for 1, and this is what we proved, essentially. This is the conditional that we proved, right? We assumed that this was true, and we proved that this was true. Thus, we proved this conditional. So, if it's true for 1, and whenever it's true of a number, it's true of the next number, by the principle of mathematical induction, it must be true for all numbers. Sheriff, we good? Okay, I wanted to do like 3 more examples. So we'll see if that is going to happen or not. I might make you guys watch a video too, I don't know. Alright, cool. There's like only 10 minutes of class, so yeah, we should turn that off. Bye, period 8.
Bye.